Hello everyone, you are welcome to today's lesson. In today's lesson, we are going to look at the solution to the class test on vectors and statistics. So I will walk you through the solution, and as I walk you through the solution, I will guide you as to how to mark, because in the solution you see marks allotted to your steps. Okay, please, this is Mr. Hackman of Omega Education Consult. Stick and stay with me whilst I walk you through today's lesson. Okay, so quickly, let's go and look at our first question and the ideal solution. An ideal solution in the sense that this is the solution that will best save your time and also your space. Okay, however, we will accept all valid, and I repeat, valid alternative methods or approaches. Okay, so now let's look at what we have here. So the points, we are told, question one, the points P, Q, and R have position vectors. Okay, so these are the position vectors of point P, Q, R respectively. Find, okay, so we are asked to find the following: the vector PQ, the vector QR, and the angle PQR. And we are asked to correct to the nearest degree. So with this one, don't forget, this is very, very critical. So this must be underlined, correct to nearest degree or nearest degree. Remember, I've told you, anytime you read questions, make it a habit. Apart from the fact that you need to study the question, appreciate the question before you proceed. Make sure you underline the salient parts. Okay, and the salient part could be any required approximation. Okay, if you are asked to leave your answer in a particular form, if you see show, if you see prove, okay, all these are basic information or parts of the question that you need to underline to have what I call your low hanging marks protected. Okay, so after reading the question, underlining the salient parts, okay, what do? We come and write solution. That's the first thing that we are supposed to write. Okay, then after solution, questions are numbered because we want you to number your solution as well. Ordinarily, if maybe in the now constrained situation where questions are given and you are equally given line space to provide your answers. Okay, in that case, once you read a question and you write solution, you can choose not to write a question number because it so implies that the solution that you have here, because the space here is provided for question one, it implies that the solution that you have here is also for that same question. That was just by the way. So as usual, you know, we are going to extract. Do you remember I've told you anytime a question is given, make it a point to also extract the information that will help you provide the valid solution that we are looking for. So in this case, question one, then given, you extract all your position vectors and take note. You can see that the position vectors came in the Cartesian form. The position vectors are in the Cartesian form, and I've told you anytime vectors are given in a particular form, in this case Cartesian form, it means any other vector that you are asked to find, unless otherwise stated, must be left in any form. I mean, in this form, not in any form. It cannot be left in any form, but in this form. Okay, and I think I'm definite on that. So if you change it to any form that you think is convenient for you and work with it, okay, your results, okay, after working with a form that you can best relate with, your result, you have to change it, okay, back to this, okay, form. Other than that, okay, you won't get the score. So take note of that. So at this point, you know, okay, these are position vectors in the Cartesian form. So you extract all of them. However, take note, if you extract, when you are writing, remember, let me go for the pen. When you are writing, when you are extracting vectors in the Cartesian form, any, okay, letter that you see in bold, you can see that that is in typing, in what do you call it, in printing, you see, okay, the vector nature indicated in bold, okay, with a letter. However, when you are writing, like I told you, so if you were writing it and you wrote just P, okay, and you didn't write tilde, it's equal to minus 4 I tilde, you didn't write a tilde, then minus J tilde. Please, it will be B0. Take note. Okay, this is how you bring out the vector nature of what you have there when you are writing. And again, if you, instead of writing small p tilde, and you wrote p, capital P is equal to this, okay, what you have here, even if you write minus 4I with a tilde, then minus j with a tilde, because of this, it will be B0. Remember, this is a point, which is not a vector, but this side is a vector. So each side must be vectors. Okay, take note of that. So that addresses that. So anywhere here that this is not satisfied, it will be B0. If this is not written as Q tilde, okay, minus P tilde, okay, you are supposed to write it, then it will be B, okay, 0. So now, what is our Q tilde? You know, okay, I should come A. Now we are going to look at the solution to A. And I know that I am going, let me go for the laser pointer. Okay, so A, and I can find this straight away. Okay, so I can draw my conclusion at this point. So therefore, my vector PQ will be equal to the Q tilde, okay, minus P tilde, but for me it will be Q minus PQ and P, okay, in bold. Okay, then what is your position vector of Q? And that is this. So you just go and substitute your corresponding vectors. Okay, you can choose, and like I told you, for you to be safe, anytime you are substituting, put it in brackets. But I showed maturity, you can equally do so. I only indicated the second vector P because the sign before it is what? Minus. Okay, subtraction. And okay, you have two vectors or two terms for your vector, both the I and the J components. Okay, so at this point, what do? We come and simplify, remove the brackets, then combine like terms, and you can see the marks allotted to that as well. So we come and similarly, in finding QR, we use the same approach. Okay, vector QR. It will be your terminal vector, position vector R minus the terminal vector, sorry, minus the initial vector Q. So you come and equally substitute, you perform your algebra, then you get this. Take note of that. However, again, if somebody writes, extract the information this way, the same thing, you will get a full score. Instead of using a special position vector notation, if you wrote maybe vector given vector OP, okay, that's the position vector in the Cartesian form. Then vector OQ, okay, in the Cartesian form is equal whatever. If you extract your position vector this way, the usual way, not the special notation, that is equally okay admitted or admissible, if I should so put it, or I should say that equally can be admitted. So, but if you write OP without the arrow on top, please take note. Okay, it's still not a vector. Take note. That was just by the way. Now here you need to be very critical. Okay, though the question didn't tell you, okay, that you are dealing directly with what do you call it, a triangle. And remember, I told you if the figure is directly mentioned, okay, in the question, then you are supposed to draw and use that as a guide. Get a rough sketch, okay, and your rough sketch, you know you are drawing lines and you shouldn't draw lines with your free hand. Use the appropriate instrument. So with this one, what are we supposed to? We are done with A and B. C, we are asked to find angle PQR, so we are finding this angle. So we, in what we have here, it means we are calling this angle theta. So we are finding this angle. Okay, angle PQR. Okay, remember I told you here immediately you know that you are looking for an angle. Okay, we should know that we are supposed to employ the use of what? The dot product. Okay, by the dot product, we call the dot product rule involving what? An angle. Okay, so in this case, what do? You represent the angle that you are asked to find by theta. And if you do that, that will be what? Half mark for that, B half. Okay, and you know, before the dot product, when you are finding an angle, will be valid. The direction of your vectors is very critical. Remember, I told you, it's either your vectors must move towards that particular angle or they should move away from that angle, the point that you can find that angle. So here, it's either your vectors are moving away. In this case, I use vector QP dot vector QR. So in that case, you can see that my okay vectors are moving away from what my points that I have here where the angle is formed. Okay, or another way is to do vector PQ. In that case, you can see that your vector is moving towards your Q. Okay, it means the other vector that you are going to dot with that should also move towards Q. So it will be vector PQ dot the vector r what q. Okay, either this one or the one that I just said, vector pq, okay, dot, okay, vector rq. Okay, if you don't use any of these two, okay, you are wrong. And you change the direction, very critical, you are wrong. So marking becomes easy from this point. Okay, so if you get the answer, you should know that it's just, okay, magic, okay, or just a sheer coincidence that you had the answer right. But okay, so it means that wasn't a valid approach. Okay, take note. So now I know that anytime I dot these two vectors when they are moving away or towards this common point, okay, it will be equal to the magnitude of the vector here, okay, times the magnitude. Let me go for the laser again. Okay, so times the magnitude of vector QR then cos theta. Remember, theta we said is the angle that we are looking for. Okay, however, we don't know the side, so we need to go and find the side. So it's a formula work, like I've told you, quote the formula and let the formula guide you. After quoting the formula, we realize that we need to go and find this. We don't know. Okay, we have to go and find, okay, the parameters here before we can find theta. So now vector QP times vector QR, you know, anytime you are dotting vectors, we know what do we do? We multiply. So we are going to get, so written in that same, so your vector QP, okay, QP. But unfortunately, you should know that you don't know QP directly, but you rather know PQ. And we've done inverse or negative vectors or negation of vectors. So we know that vector QP is the negation of what? Vector PQ. So that would be equal to minus your vector, okay, PQ dot what? Your vector QR. QR, we know that directly. Okay, so otherwise, someone will, so because you realize that you don't know vector QP, but you know PQ, maybe you don't want to use the inverse, which is the ideal approach. You can still do the position vector of P minus the position vector of Q. You will waste time. So this is the ideal, like I told you, presentation. So anytime we are dotting, we multiply. So here I push the negative through. So push the negative. So simplify negation of this first before you know the actual vectors that you are dotting. So here you multiply corresponding, okay, what do you call it, components. So it will be the minus 5 times minus 6, then plus, okay, this one times that, which when you simplify, you come and get this. So take note of the marks allotted there. Then we also, like I said, we don't know the magnitude of vector P, QP. So we can find the magnitude of vector QP. And the magnitude of vector QP will be the same as the magnitude of vector PQ. Okay, however, you know that vector QP is this vector. So you can extract it from here. So it will be this one squared plus this one, okay, squared. So that's what you have there. Okay, so if you continue, you simplify, you end up getting what we have here. Okay, so if you forget the units, okay, it will be A0, take note. Okay, all right. Okay, so then we come to this one as well. Okay, the same way, you know how to find the magnitude of a vector. You know the vector, okay, QR. So your x component squared plus the y component squared, root of that. Simplify, you come and get this. So once you know all your parameters, you just go and substitute. So this implies that you know this side is what you found here. This is equal to the magnitude what you have here cos theta. So now the only unknown parameter is theta, which is what you are looking for. So let's move on to the next one. We are still on what? On the C. So this implies, you know, you write it again before you divide. Okay, someone can multiply the whole of this first. Okay, so in any case, that's what I did. Then, okay, you divide. Okay, then you simplify, you know, we are looking for cos. So this will give us cos theta is equal to this. Okay, theta will be equal to cos inverse of what we have here. Then your first approximation must be 4dp. Before, remember, you underline the salient part. Okay, and you know that before you move on to your next question, you have to subject your solution through what you have underlined. And after doing that, you realize that the question asks you to leave your answer in terms of the angle to the nearest degree. So this one is 4dp. So the nearest degree will be 29 degrees. The total mass for question 1 will be 25 mass. Okay, so take note. Now this takes us to question 2. Question 2, also a very interesting question. We were given these three forces. Okay, we are told that act on a body. Calculate A, the magnitude of the resultant, B, the direction of the resultant, and C, okay, will be the force that will keep the body in equilibrium. So as usual, solution, question number, given, you extract the information that you are giving. So here we're giving these three forces, so you extract B half. Okay, and you should also know A. Now we are coming to find the magnitude of the resultant. Before you can find the magnitude of the resultant, we need to know the resultant. Okay, but we know that the resultant force R will be equal to F sub 1 plus F sub 2 plus F sub 3, the sum of the three forces. If you're able to state this, B half. Then you know, because the forces came in the magnitude bearing form, they are not friendly form in terms of algebra. Okay, so we have to move, okay, the vectors or the forces in this case to in the magnitude bearing to either the Cartesian or the column, but preferably the column form. Okay, so we know the way or the formula for moving any vector in the magnitude bearing to the, what do you call it, the column form. Okay, if you have forgotten, please go to my YouTube channel, Hakimatics, okay, and you get the lesson there, review the lesson, then maybe you come back. But the form is a formula way, so that will give us your magnitude of the vector, okay, then sine the bearing of the vector. That will be the s component of the column, and the y component of that vector will be again the magnitude and cos what 120. If you do this, don't forget, it means you are resolving your forces along the positive along the s axis. Okay, the other one where cos and sine, cos comes first, followed by the sine. That one, the resolution is done along the y-axis, positive. So in this case, what do we do? Just a formula. Each vector will be magnitude times sine the bearing angle. So you come and do same for F2. Okay, my magnitude sine, okay, magnitude cos. Magnitude sine the bearing, okay, the magnitude cos the bearing for the y component. And here the bearing is 3 digits, but I've told you, anytime you are substituting, take note, okay, your angle substitution, if you have 0 before it in your, what do you call your bearing, okay, don't write a 0, take note. Okay, so now this will be what you have here. And again, in your substitution, don't forget the degrees. Okay, if you forgot the degrees, it will be minus half, so you get m half. Okay, at this point, the rest will be calculator work. Use your calculator to get it. Don't approximate. Okay, use your calculator to get. So leave your answers first of all insert. Then now you come and add and approximate. Okay, take note. Okay, you have to reduce the number of approximation, okay, as much as possible so that you don't move away from the actual or the accurate, okay, value or values. So in this case, if you sum this, your calculator will give you your result insert, but take it to decimal, but you approximate for DP. Come and do same for the y component, and you get this, take it to 4dp. Make sure your 4dp approximation or roundups, okay, are concise and precise, are accurate, if I should so put it. So now, because you approximated, I've told you, anytime you approximate, don't forget to indicate your approximation. So if you forgot, it will be minus half, so you will get a half instead of a 0. So I'm being lenient here. Then now, okay, that we know, what do you call it, the resultant in the column form, we can easily find its magnitude. Okay, so please forgive me. Let me do something here. You see, this one was supposed to be here, and it is now here. So I need to move it back. Forgive me. Okay, so I think, let me quickly go and rectify that. Okay. Okay, so I have effected the change. So now we are finding, we're going to find the magnitude of the resultant. So because we usually want to avoid concluding with what we introduce, in this case R, okay, instead of writing therefore R magnitude, okay, which is the magnitude of the resultant, use the resultant, okay, straight away. And that will be equal to root of the s component squared plus, okay, the y component squared, you know. Okay, and this one calculator work, that gives you this. Okay, forgive me, calculator work, that gives you the, but these two are approximated to 4dp, and I've told you, anytime you approximate, don't forget to indicate your approximation. Okay, if you fail to do so, m half. Then I've told you equal to is a very sensitive sign. So anytime you are writing what is not exactly there but is truncated, approximated, indicate your approximation to keep the equal to value. So at this point, you sum this, okay, root of that, and that gives you this. If someone moves from here straight away to this, you will get the M, so you come and write M1, A1. So you get the 2 marks. And this one too, okay, the square root is approximated to, okay, 4 dp. Okay, so if you fail to indicate your approximation, minus half. If you fail to indicate your unit, A0, take note of that. That's your conclusion. As for if the unit is not there, it will be A0. But if the 4dp is not there, it will be minus half. Take note of that. Now we come to B. B, what are we supposed to find? The direction. And you cannot get the direction, which is the same as the bearing, okay, without drawing in this situation. So once you know the resultant in the column form, you should know the quadrants, okay, that your resultant force, okay, is in. Okay, so if you look at this, the x component is positive, the y component is negative. So it means you need to move in to the right direction for the 15 units. In the y, the 15 point, this unit, okay, and this unit down. So you move here 15, so as indicated, you come down. Okay, the negative is catered for, okay, by you moving down. So there shouldn't be any negative, okay, here when you are dealing with a side. So remember, let me go and pick the pen. So this is the angle. Okay, you need this angle, and this will always be 90. So if you want, you can, okay, and I will advise you to indicate, and this will be your X, this will be your Y, which happen because we are going to find the bearing. Let us know that that is your true north. Okay, let me write it well before somebody, okay, assume what you have there is N sub Y. Okay, so let me write it directly on top of the Y. Okay, so this is what you should have. That's your north, your true north. So in this case, if you draw the diagram correctly, okay, if you indicate negative here, it will be minus half. I think I should even make it minus 1. Okay, and if you want to find a bearing, you know, bearing angles are measured, okay, clockwise, okay, from the true north. So it will be the whole of this angle. Okay, and that will be equal to, from here to here is 90. Okay, now let me pick my pointer. So from here to here is 90. And now if you're able to find theta, you know the bearing. So the direction, which is the same as the bearing, will be equal to 90 degrees, okay, plus your theta. So how do you find theta? You take this right angle and you know the opposite, you know the adjacent. So you come and use the appropriate trig ratio, in this case tan. So tan theta will be equal to the, let me see whether I did the right thing. No, I did not. So I need to go and work on it. So there is something wrong. I did rather the, what do you call it? The adjacent over the opposite. But it's supposed to be opposite over the adjacent. It's always y over x. So there is a mistake there. Let me go and correct that. Okay, so that you use it to do the needful. So quickly, let me, okay, pause, then come back. Okay, so now, okay, I think we are good to go. So just as I was saying, you know, we need to find theta. And theta, we have to use tan because this right angle triangle, we know. And let me equally, if you want to do this, which maybe I will advise you to, okay, right, you know, the vector that you have here is your resultant. So that's the magnitude of your resultant. So indicate, okay. All right, so in this case, this is what we are supposed to opposite over adjacent. So it will be tan theta is equal to the opposite to this angle, which is this, over the adjacent of the triangle, so this side. So what is what we have here? Then theta will be equal to tan inverse of this. If you use your calculator, then here, again, someone can choose to approximate, okay, and use the 4dp approximation and come and write it here. But remember, I've told you, I usually want to avoid, okay, or reduce my number of approximation, avoid doing a lot of approximation, just for the simple reason that it can move you away from the accurate value. So in this case, I will not approximate this, then come and find tan inverse, then approximate 1. So you, if you approximate here and you will do approximation twice, but I have done approximation once. Okay, so I'm more likely to get a precise answer than yours, or an accurate answer than yours. So now that you know theta, you know your direction or the bearing. So you don't go and draw your conclusion. Therefore, the direction of the resultant force will be equal to, remember, it will be your 90 plus what? Your theta, which is what you have here. And if you sum, you are going to get this. Okay, and again, I decided to leave my answer in 4dp. Okay, if you want to change it to any other approximation, you can. But here, there is no required approximation and there is no convenient approximation. So you can end with a 4dp just as we did for the resultant. So that will be it for B. Now, quickly, let's go and look at the C. Okay, C. Again, look at the question. We are given these, okay, three forces. Okay, acting, I think, yeah, this is C, so it's a continuation. So let's go and look at what? Question C. We were asked to find, okay, forgive me, I thought maybe I'll move on to the next question, major question. So we need to find the force that will keep the body in equilibrium. So we need to introduce another force. And that force, we are going to represent that by F sub 4. Okay, so you let F sub 4 be equal to what? The force. Then, but for equilibrium, you should know this. The sum of all the forces at play should give you 0. Okay, so it means your F sub 4 that you are looking for will be equal to, okay, you have to move the whole of this to the side. So it will be minus, because it will be minus F1 minus F2 minus F3, which is the same as minus F sub 1 plus F sub 2 plus F sub 3. But we know that F sub 1, F sub 2, F sub 3 is the same as what you labeled in A as for what your resultant. So it means F sub 4 should be equal to minus the resultant. Okay, so if you are able to state this, okay, you get your B half as well. However, someone can move from here to here straight away. If you were part of those who did that, then you wouldn't lose any marks. You get your B1 for that. So this mark will be added to what you have here because you should equally see that. So that's the matured way. Then after that, it will be minus. Remember, you know your R, so don't go and find that again. You know the sum, unless you don't trust yourself. That's what you did when you were looking for the magnitude and therefore the bearing. So now you come and you just go and pick your R. So it will be minus that. So you multiply each of the components here by your negative, and that gives you this as what? Your F sub 4. But you cannot conclude this. Remember, because the forces came in the magnitude bearing form, any other force that you are asked to find equally must be stated or left in that form. So now you know F sub 4 in the column form. So you should take this force in the column form to its magnitude bearing. So what do? You go and find the magnitude. And you know indirectly the magnitude will be the same as that of the magnitude of R. Okay, so only that will be applied in another direction. Okay, in the opposite direction. That's why you have the negative. So now what do we do here? It will be your S component here squared root of m plus your Y component squared. Okay, again, so with here you can infer because it's basically the same as what we did here. It's basically the same. Doesn't really matter the signs attached because it's going to be squared. So you end up getting the same result. Okay, so you can infer just as I inferred over there. But I approximated this one too, and you can see the way I did my approximation to the nearest, okay, newtons. I didn't give any marks there. Okay, so remember because the forces came in the whole number, okay, values in terms of the magnitude. That's the more reason why I also have this one in the whole number. So that when I'm concluding, I'll conclude with the whole number. You can ignore this and do that when you are dealing with the whole number presentation. So if you use the approximates or the equivalent sign, you don't indicate, or you can choose not to indicate your approximation. The best way is not to indicate. You've already indicated that it's approximated. Then bearing of your F sub 4, okay, will be equal to, so now you are going to use this. Okay, that's the F sub 4. So that will tell you that you need to move, okay, in this direction, in the negative direction for the X, okay, and in the positive direction for the Y. So at this point, this is what we are looking for. So your 90 will be here. Okay, the bearing will be from this angle, okay, up to, okay, from that line up to that's the angle. So that will be your Y, which is happen to be your true north, and your X. Okay, don't forget. So if you're able to get your theta, which is this angle here, you know the entire angle. Because from here to here is 90. Let me pick the laser once again. Here to here is 90. Here to 180 plus another 90, 270. So it will be 270 plus theta. That will give you your bearing. Okay, so now the bearing of F4 will be 270 plus theta from the diagram. And if you draw the diagram correctly, it will be your 1.5. And equally, let me indicate the vector. Just as so, this is the vector F sub 4. Okay, and that will be the magnitude of that vector. Okay, so if you are good to go, then at this point, this is what we need to do. Let me go and pick the laser again. So you find theta, and theta will be opposite over, which you have done already. So you can write, but tan theta is equal to this, because it's the same right angle triangle that you had in the other situation. So if you like, you can come and substitute, or someone can move from here to here, knowing that what you had there is the same as what you did previously. So if you do that, then your M1 here will come here. So it will be M1A1. So that will be your 4dp. Don't forget your approximation. Then now we are looking for the bearing. Now that we know theta, you just can go and add it to 270, and that gives you what you have here. And again, I approximated this one to the nearest because of the form here. Otherwise, someone in the conclusion can leave this one in the 4dp, conclude with this Newtons, then comma the bearing, use this 4dp, but I decided to make it pretty because of the form. So I concluded with the nearest, okay, whole normal approximations, nearest Newtons and nearest degree approximation, and that will give me this. So the total mass for question 2 will be what? Will be 29 mass. Take note. Okay, so we are through with question 2. Now let's go and look at what question 3, another interesting question. And this question, remember, okay, indirectly was given to you, okay, and you were told that it will come in the. So it's a question that I expected everyone to get it, because it was more or less a bonus question. You knew that it will come. So let's look at question 3. It's in A and B. So let's look at the A first. Given, okay, so once this is bold, you know that it's a vector in the column form, a position vector in the column form, position vector of R. Okay, and find S if the magnitude of the vector S, so if this is a vector S because it's bold, is equal to 35, and S is in the direction of. So this is the directional or direction vector. Take notes. Okay, so here, as usual, after reading the question solution, question normal, then you come and extract. You can choose not to write the given and you extract this. When you are extracting and you are writing and you write the small p, you don't write the tilde. Okay, please, it will be B0. Take notes. Other than that, what you are working with will not be a vector. So QR, okay, all of them must be tilde, small letters. S must also have tilde because it's in bold. So you extract, but you know, you have to let, in your mind, you know the formula that you are going to do. So you represent your direction vector by what? D. Okay, so instead of giving, maybe you could have added this one here, then maybe come and write let's D. Okay, but I decided not to do that. So I extracted it by giving it a name. So the vector D, and the D2 should have your tilde is bold, you should know. This is indirectly in print, okay, or it's typed, so it should the vector data should be brought out by, okay, using the bold, okay, letters. So now you know after this, you know that S, any vector that you are asked to find, okay, the same as it should be equal to the product of the magnitude and the unit direction vector. So quote the formula. Okay, so after quoting the formula is telling you that you need the unit direction vector. S magnitude, yes, is given. So that one is no, you know. What you need to go and find is what the D cap. And you know that the D cap, okay, is equal to the vector D over, okay, the magnitude of D. D cap is the unit vector direction for the D. So you come and you don't know D. So once you know the individual vectors, you can go and find the D, which will equally come in the column form. So that's what you substitute, you simplify, and that gives you this. Okay, and take note here, you have to move the scalar in before you can add everything. So this, your next step, push the scalar in before you can. Someone can push the scalar in here and come and combine this. In that case, you have two vectors here. Which one will be this one with the scalar multiplying each of the component, then with the sum of this. Okay, then you still end up getting this as what your D. Now that you know that this is your D, you know D, you need the magnitude of D2 before you can find the unit direction vector. So you know how to find the magnitude of this D. So you set out to find the magnitude by using the formula. And don't forget, without the unit minus half. Okay, then this implies once you know your D, okay, and you know the magnitude of D, you can go ahead and find the unit direction vector. So come and substitute over, so you've done your substitution, the D over its magnitude. So you know that this is the same as each component divided by this, or is the same as 1 over root of 442 times the whole of this. So each component, okay, times 1 or divided by that. So that's what you have here. Okay, so you know, okay, now that so you know your D cap, not pretty. Someone can leave this one in terms of decimal, it's allowed. Okay, only that you should leave it in 4dp. I decided to work with what? The exact, okay, and maybe approximate, okay, when I'm concluding. So I can avoid approximation here. So that again, I will end up getting a more accurate answer. So in this case, therefore, the S that I'm looking for, I know the magnitude, it was given times the unit direction vector that I needed to know before I can find, which I have done, found that. So we have found that you come and substitute, then it will be each of the component times the scalar. So that gives us this. Okay, and you know you cannot end here because when you were doing set, you've been told you don't leave a set, okay, containing a set, a fractional set or a fraction set containing a set in the denominator. A fraction, you don't leave a fraction with a set in the denominator as your final answer. So you can feed this with your calculator, and maybe your calculator will give you the decimal, I'm sure, because of the value, okay, the huge numbers that you have there. However, you can equally do this mentally. Numerator, denominator times root of what? 442. So this will give us this times root of 442. The root of 442 times root of 442, which will give you root of 442 squared. So that will give you 442. 444. So you do same to what you have in the denominator. Okay, so that will give you this, or use your calculator at this point to do this, which will give you this. Okay, in approximated form, do this, which will give you this. Okay, so don't forget you approximated to 4dp. So you leave your answer in 4dp. That will be it for A. And B, take note. The B here, I think, yes, the B is the recent, what do you call it, WASI. Okay, for Ghana. Okay, the 2024 WASI. Okay, one of the questions, I picked it from there. Okay, so an interesting question for that matter. It didn't come in the usual form that you see rank correlation coefficient, Spearman's, okay, to be specific. So let's read the question. The Spearman's rank correlation coefficient of 20 marks in 2 tests, okay, is this. So you've been given the Spearman's correlation coefficient, you know your coefficient. Find the summation of d squared. Okay, so summation of d squared are the sum of the squares of the rank difference for each pair of ranks. So you know this, even without this information, you should have known that that is the meaning, okay, of what you have there, if you have done that particular, okay, topic. And those of you who have not done that, please go to my YouTube channel, okay, and watch it. And that will be, okay, so once you have access to this video, you can have access to my channel. And don't forget to subscribe as well. Okay, so, and share. Okay, so you can equally like, I should say, that was just by the way. So solution, that's what you write. Okay, in any case, we've written the solution, okay, for that major question. Okay, 3, you write, like I advise, usually write your solution once for every major question. So don't write it for sub questions. Okay, and it should always be on top so that the sub question, okay, that will follow will be affected by the solution. The solution will affect it. So now 3B, okay, you know that the Spearman's rank correlation coefficient, okay, comes with a formula. So quote the formula and let the formula guide you. So the Spearman's rank correlation coefficient, usually denoted by small r, okay, sub big S, or S for Spearman's, is equal to quote the formula. And if you're able to do that, B1. Okay, let the formula talk to you. In the formula, okay, I would need my N. I will need my sigma D squared. Okay, so do I know my N? Let me go to the question. Yes, the N will be the, what do you call it? The 20 marks that we have here in 2 squares. So this will be your paired observation. So the number of paired observation. So in this case, okay, you can extract. It doesn't really matter which one comes first. So, but R sub S, you are giving the R sub S2, you know this as well. So, okay, usually you will not be given this and you'll be asked to find that using this formula, okay, where you'll be given the data set, okay, your paired observation, okay, if they are ranked, you don't rank, you go and find, if they are not ranked, you go and find rank of X, rank of Y, find their difference and you move on. If they are ranked, you just go and find their difference, then you square, okay, then you sum. Okay, so here we know n, so we are good to go. We know, so just come and substitute, and the rest will just be, okay, algebra, change of subject. So you substitute R sub x, okay, which was given, so you extract that as well, B1. At normal circumstance, this one can come up, okay, you can extract as well before, like we've always been doing, okay, giving this and end. Okay, all right. So now substitution. After substitution, you come and you can work on, okay, this. Okay, so come and work on this to make it very easy for you to work on in terms of algebra. Okay, so compute. So now what do we have here? 20, come and work on what you have in bracket. 20 squared will give us 400 minus 1. Okay, keep whatever that you have here. Come and work. So this will give you 399 times 20. So someone can move from here, okay, to this straight away. Take notes. Okay, you end up getting the same, okay, mass. Only that usually I've told you if you have a power, okay, which is more or 2 or more, and what you have there is not 0, it's not 1. Okay, make sure you deal with that before any other thing. So you substitute, okay, and you simplify, and that gives us, if you multiply this, you end up getting this. But we are looking for this. Okay, so what do? We need to, okay, move the term that contains what we are making the subject. We need to move it to this side or isolate it. Okay, so make it stand alone. Or someone can multiply through by the denominator, clear the fraction here. But I didn't do that. Okay, I moved this one to the side and brought this one here just because it was negative. So that gave me what I have here. And after simplifying the side, now I can multiply, clear the, so it will be this one times that, which will give me what I have there. Okay, and you know I'm looking for this, okay, with the coefficient being 1, but the coefficient is 6. So I write it again before I divide. Okay, and by so doing, I will end up getting this. Okay, if you like, you can attach 0. Usually we leave our answer in 4dp. Okay, but this is equally, okay, the same. Is okay, so it can also be your answer, and it can be admitted as your answer as well. So that will be it for question 3. Total marks will be what? 26. So now let's look at, okay, the last, okay, question. An interesting question for that matter. And this question was also taken from, I think, the WASI 2024 Ghana. Okay, the vectors and mechanics section. Okay, take note. So if you're able to do this, it means, okay, that question, if you happen to be part of the students, okay, who wrote the paper, you would have been able to give, okay, the full score. So extract the forces given, B1, all the forces, all the information that you have there, the mass, the what have you. If you extract everything, B1. Okay, now let's see, we are asked to, okay, if the acceleration is this, find correct to the, so in this case, you know, okay, you should also always know, okay, that this information is very critical. Okay, so here you should know that by this, okay, Newton's law of, okay, motion or force, if I should put it that way, you will get F is equal to ma. So F force will be equal to mass times acceleration. The acceleration is given, the mass is given, okay, but the force, okay, you were not given only one. For the force here is referring to the resultant force. Okay, or someone can use R is equal to what you have here. Okay, in that case, you don't write this, where F is equal to the resultant force. Okay, you can write resultant force R is equal to this. It's the same thing. Okay, so now what do? We need to find the resultant, which will be the sum, because we said F is the resultant, which will be the sum of all the forces which came in the magnitude bearing form. Okay, so if you are able to find the K and what and the alpha here, you know F sub 4. So that's all that you are asked to do. So again, okay, you need to underline this correct to, we didn't read the question in its entirety, so find correct to the nearest whole number, you underline that. So if your final force is not left in that form, whole number form, you won't get the final answer score. So you know, your magnitude sign of the bearing, okay, magnitude cos of the bearing for the y component, x component, all of them will be magnitude sign of the bearing, y component, all of them magnitude cos of the bearing. So here, this gives us all that we have here for all the forces. So your sum of the four forces should be equal to the mass, okay, times the acceleration, which you must also take to the column form. Okay, so before you can equate. So that gives us, with this one, you should know special one. When we say that the bearing is 90, it means it's on the positive x-axis. So the y component automatically will be 0. Okay, on the x-axis, y is, okay, 0. So that gives us 15, 0. This will also be on the y-axis, positive y-axis. So on the positive y-axis, x is 0. And okay, so that gives us this. Or better still, you can use your calculator. And your calculators will give you, don't write the approximated version of this, use the exact version. And this one too will give you k sine alpha, you know it is the magnitude. Where is the f sub? It's the magnitude sine of your angle. Okay, then, okay, magnitude cos of your angle. And that will be equal to mass, which is 1.2 kg. Then the acceleration, which if you take to the column, will also give you magnitude sine, magnitude cos. So at this point, you use your calculator to do that as well. I think I explained that. Look at the mass allotted and do the needful. So now what do we do? We are saying this side must be equal to this side. Come and simplify this side. I know if I add the y component on the side, this and this will cancel, so I'll be left with only this. So that will give me the simplified version. The s component will be the one that this will cancel. And there's a y component. What do I do? I equally come and add this, and that, and this. Okay, so what do we do? If you add these two, okay, you are going to get this. Okay, write the approximate value there. Okay, then what do we do? This will give you plus k cos. Okay, then you can't add this one to this directly, just as the other one. So these are the values that you can add, but this one you can't add it directly. So you end up getting two terms. One for the addition of this, which will give us this result approximated to 4dp, and this. Then you come and do this one to multiply, because you've done approximation here to 4dp. Come and approximate this here as well. Okay, this one will give you 4dp approximation. This one is the exact, okay, not an approximated value. But because we've approximated here, indicate your 4dp. So meaning any approximation that anyone sees here is to 4dp. Then at this point, you deal with equality of what? Of vectors. So when two vectors are equal, it means their corresponding components are equal. So this implies that, okay, this is equal to that. And I label this as equation 1. This is equal to that. And because I can simplify, I didn't label my equation at this point. Okay, I moved on to move this one to this side. Okay, then before I labeled. And even this side, I attach any marks there, because you can use your calculator to do it and move from here to here straight away. Okay, so there is no marks here. Then at this point, we are asked to find the values of what? Of k and alpha before we can. So what do? We are going to solve these two equations simultaneously. And it will be better you do equation 1 divided by equation 2. Okay, so that the k will go and you end up getting tan. Okay, so in this case, if you do that, you are going to get this divided by that. Okay, is equal to this divided by this. So that's what we have here. That takes us to the next, okay, page, and we are going to get tan alpha, because what we have here, take note, k will cancel and to be sine alpha over cos alpha. And we know that sine over cos is tan. So the same angle, so tan alpha. And that will be equal to this, and this will cancel. So I only cancel the negative. And if I were to divide, I would have approximated. Then when I take the tan inverse to approximate again, like I told you, I want to reduce my number of approximations. So that gives me, okay, I will leave it, just cancel the negative and leave the rest there. So alpha will be equal to tan inverse of whatever that I have here. Now I can use my calculator to do this and approximate to 4dp. And call this one 3, because I will need alpha to find k. Okay, and here alpha is to the nearest whole number. Okay, take note. So that would be A1. Okay, all right. Okay, the question didn't ask you directly to find alpha and k. It asked you to find your F4. So your F4 must be stated in this form. That's how your conclusion will be. Otherwise, someone can come and write, therefore, alpha is equal to this. Okay, then go and find K and draw the conclusion as such. Okay, in any case, it's allowed. Okay, so what do we do here? We are done with alpha. Now, before you can find K, you need to go and substitute alpha into any of the two equations. That's why we labeled this as 3, because we would need it. So equation 3, and I've told you, don't write equation. Okay, I'm repeating this. Don't write equation 1 this way, equation 1. Okay, just write or equation then 1 in brackets. Okay, take note, just write this is read as equation 1. Okay, and those of you who wrote put substituting, I've told you, just write equation. So this one will be read as equation 1, so equation 3 into equation 1. Don't write put, don't write substitute. If you want to write, then you have to write putting, substituting. Okay, use the continuous one instead if you want to write. If you are difficult and you still want to write that, that is what you write. Don't write instead of put, write putting. Instead of substitute, write substituting. You are substituting, you are putting. Okay, don't instruct the person who is marking or reading your or will mark your work. Okay, take note. So that was just by the way. So if you wrote putting, it will be -1. Okay, because I've advised you severally. Okay. All right. So take note. That is the penalty that comes from you being recalcitrant. Okay. So now what do we do? If you go and substitute, okay, the 3 into equation 1, this is what you can see that this is your equation 1. Okay. So equation 1. So wherever you see alpha, that is your equation 3. Substitute that. So that gives us what we have here. But we are looking for K. So instead of approximating this, then later come and divide and approximate. Okay, I decided to keep it. You can approximate anyway. Like I've told you, I always want to reduce my number of approximation. So I would write it again, exactly the same thing. Divide. Okay, then now this will cancel that. I'll be left with K here. Then use my calculator to do the whole of this and approximate. So to 4dp. The answer is negative. You know that K is magnitude and it cannot be negative. Okay, so when you are drawing your conclusion, you draw your conclusion with the positive. So take note, I think I should have used the pointer, the laser pointer instead. Okay, so now we are almost done. So at this point, this is negative, but you know K cannot be negative, magnitude cannot be negative. So you get the positive version of that. Okay, so you take the absolute value, which will give you 19 to the nearest whole number. So therefore, my F sub 4 will be K is 19, okay, 90, so it will be 19 newtons. Then alpha gave us what? 49. Remember, it's bearing. Because it's 2 digits, bearing angles are okay indicated in 3 digits. So you precede it with 0, and that gives you F sub 4 in the magnitude, equally in the magnitude bearing form. And this is the interpretation for those of you who would want to know why it is negative. Okay, the interpretation I have indicated that here. Okay, the negative value of K just indicates that the direction of F sub 4 is opposite to what we initially assumed. So if you assume that it was in this direction, now upon your calculation, you realize that it is in this direction and vice versa, as simple as that. Any direction that you initially assumed, it is now opposing that, as simple as that. So question 4 will be 20. So in all, the total marks will be what? 100. So 100%. Okay, mark your scale, score yourself, and make sure you indicate your score over the total score on top of what your first page, you know the rule, and boldly written and captured. You capture your mark version for me to go through and see whether you did okay a good work in terms of the marking. Okay, and okay, please, okay, at this point, okay, thank you very much. God bless you for your attention and for sticking and staying with me. Please don't forget to subscribe to my YouTube channel. Okay, you can equally like and share and comment after going through. If there is anything that you didn't relate or you couldn't relate very well, don't forget to okay send your whatever that you have there via the comment. Okay, thank you very much. Okay, once again, God bless us all.